So another really important component is TF chain. Because in the library where you can have a look at ZeroOS, I spoke about having a ledger, having a notebook, and TF chain is that notebook. And TF chain is a notebook that is purposely built to actually contain, store, and always have available space to store workload definitions in, and space to store smart contracts in. And TF chain is built on Polkadot Substrate technology. And we really adopted that technology because it is so scalable. In the end, we want to reach numbers that are millions of 3 nodes out there. Again, being a competitor, maybe not a competitor, but at least being a challenger against these large clouds. And in order to be a challenger to those large clouds, you need to have large numbers. And those large numbers also need to have then a large quantity of TF chains that they can work with. Otherwise, it's non-scalable. If it would be one chain, one blockchain to work with, then obviously we all know that blockchains have their limitations, and having all of those millions of nodes use one blockchain, that wouldn't be scalable. So we've adopted the technology to make it scalable, to be able to run multiple chains for multiple groups of servers. And again, you can then start thinking of how would we scale that up? Well, we use 1 or 2 or 3 chains for a particular country, or we would 1 or 2 or 3 chains for a particular continent. Depending on how this grid grows, we can actually slice and dice it into sections where all of the different parts of the world that are part of this TF grid will actually use a particular chain. The chain is there. The chain has been set up to scale and support this. And this is the way we actually will allow all of those 3 nodes to actually find what they need to be doing, and for all of the economical transactions, all of the value transactions, all of the payments to happen as well. One more fact, and don't forget this, because this is really important how we do it. A 3 node will discover what it needs to do by reading in a ledger, by reading in a notebook, what its workload is that we covered. But now comes around the corner the actual benefit of doing that in a blockchain. Because why would we do it in a blockchain? There's other ways of doing that as well. Well, a blockchain has 2 really important elements. One is every data that's committed to a blockchain is immutable. It cannot change. The second aspect is the data being committed to a blockchain, that's why it's blocks of data with a chain connecting to each other, is always append. So every new piece of data, even if it is a change of an old piece of data, will be linked towards previous blocks of data. And if you combine those 2, you have created the unique aspect of where we can find autonomous operations and where we can find self-healing capabilities. Because once we start a workload and we define a workload, that definition is there forever. Once we or the developer changes that, it's going to have the original information plus the change. Both pieces of information are available on the chain. If the developer makes 100 changes, you will have the whole history of the older changes available in the chain. Therefore, if and when, for whatever reason, electricity failure, connectivity failure, a particular part of a workload fails, restarting it is as easy as going back in time, reading the whole definition of what the workload needs to be, and then just restart the missing components. That's a really important aspect of what we do, and it's helping us tremendously to get to this self-healing capability.